Hi, buddies. Today I have come up with an interesting topic called monolithic architecture versus the microservices architecture. As the name suggests, monolithic is a software build and deployment architectural pattern where all the components of a particular application or a program, including a presentation layer, business logic layer and the data layer, everything put together as a tightly coupled single unit, the single process. So that pattern design approach is called monolithic architecture. So the entire application is built into single large program where different functionalities are integrated into one application. For example, this represents the monolithic architecture where you could see, the client access, say for example, a web application where the UI layer, business layer, and the data layer, everything is coupled as one single WAR unit. So that's how it is designed. And there are pros and cons with this architectural approach. The pros are simplicity. So basically, you have a smaller application with small teams which are tightly coupled and integrated. Then this is the better approach. Better performance because you don't have any overheads where that you do have a lot of network connections, latency, and stuff like that. So less overheads and better performance. What are the con side of it? Why a lot of organizations are moving or moved to the microservices architecture? The scalability constraint. So basically, if you want to scale this application, you can do only vertical scaling, meaning that if you have a server and you have to improve the scalability, that you have to cater to larger users and peak hours traffic, then you have to increase the CPU and RAM of that particular server as a vertical scaling. So that's highly expensive and inefficient. And deployment and challenges due to the highly dependent nature of this architecture. Say, for example, you have to do something in the business logic, a change to meet a customer need or a business need, then you have to do the changes in the business logic, but you have to test everything, deploy everything. So the lead time is quite higher. So those are the pros and cons of monolithic architecture. So what is a microservices architecture? So like I mentioned, here also is a three-tier architecture. You have a presentation layer or the UI for the user to interact with, and then you have the application logic in the business layer or app layer, then finally the data layer. It's the same simple three-tier architecture, but the difference is these layers and these functionalities are divided into smaller independent modules like this. So you have the PC or mobile where you access the app, the load balancer is actually distributing the load across different servers. And then the app layer has different services, service A, B, C. For example, if you're accessing an e-commerce application, then your shopping cart will be a different service, your order will be a different service, payments and checkout will be another service. So those are like modularized, highly independent services. And then the data also is structured in a way it's highly available and resilient. The pros are agility, because if you want to do any change in service B, you need not touch anything on service A and C. So it's highly flexible. Scaling is possible with horizontal scaling. If you want to increase the capacity, the CPU or memory, you just add one more server in a highly available failover mode and scalable mode. So it's easy to scale, easy deployment, change management. Like I mentioned, you need not touch anything, just particular service you can do the changes. And fault isolation, one service is having an issue, then you can touch only that, or you have a high availability mode, then the fault tolerance and resilience is high in this architecture. That is the reason a lot of organizations have already moved to microservices architecture or moving into that, even their legacy systems into microservices. The cons are network latency. Since these services are communicating through network and the protocols, the complexity is high, the overheads are high. Those are some of the cons. Now we are going to talk about the e-commerce system design in both monolithic architecture versus microservices architecture, so you can clearly see what are the differences and how it works. Let's go. So let's first talk about, when you talk about system design, first you have to start from what are the requirements, what are you going to do. And the functional requirements are, so say if in e-commerce the user should log in and authenticate themselves. So for this scenario, let's assume that the user should log in and authenticate, but where scenarios where the user can search for the product even without logging in. And then they can search for the product, that is another requirement. Shopping cart, so they should be able to add and remove from the shopping cart. Place the order, once they finalize the shopping cart, they have to place the order by giving the checkout and payments. That's another requirement. Then they should be able to see the order status as well, and the shipment tracking, and then the recommendations on your homepage based on your browsing history, purchasing history, and stuff like that. Finally, user should be able to write the reviews and they read the reviews. So those are some of the functional requirements. What are the non-functional requirements? So the e-commerce app should be highly available, because otherwise the user comes and checks every time it gets like no access, 404 error, then they may not be able to come back, or even if they are using, they will abandon the usage. So high availability is very important. Low latency, so it should not buffer. So low latency is important. High scalability, so if there are multiple users during prime days, peak hours, then it should be highly scalable. Security, so of course security is very important, and also high consistency. So some of the data should be highly consistent, for example your payment details, your order details, and stuff like that. So now we understand what are the functional and non-functional requirements. Let's move forward with the design part of it. So in a monolithic architecture, so the end users are accessing the service, and the service is structured in such a way that you have a firewall, so that any malicious traffic can be filtered out, and there is a load balancer. The load balancer will distribute the load across different servers. So it's a one on-premise e-commerce infrastructure which is built and deployed as one single unit. That's how the monolithic architecture is. The end user is accessing. First the request goes to the web server. The web server caters to any static requests, so basically the product images, logos, banners, any other visual elements. And if they are not able to cater, so it's large business logic is required to process the request, then it forwards the request to the app service. The app service has the functionality. For example, in this case is a monolithic architecture, so we assume that everything is actually one application, starting from logging in, search for the product, adding to the shopping cart, and adding to the shopping cart, and then checkout and payments, and finally order tracking and stuff like that. All the functionalities are integrated into one application, and the database will have all the user profile information, the address, the payment information, and the product information. So it queries the data and processes the data where required. So everything is built into one single large application. That is the e-commerce monolithic architecture. Like I mentioned, the web servers serve static assets, application server process e-commerce business logic, databases store user and other dynamic data. So now let's see how it can be designed in a microservices architecture. Here we go. In the microservices architecture, I have taken AWS Cloud Computing as a base, where this is hosted. So the user, the consumer access the application, and you put like www.amazon.com or flipkart.com, then that is resolved the domain to IP address using the domain name service. So here we are using Amazon Route 53 as a domain name service, and then the request is going through the Elastic Load Balancer. Like I mentioned, the load balancer is helping the user requests to be distributed across different web servers if multiple users. So for example, if there are 10 million active users at single point of time, then the server, the application should be accessible. So we have to distribute the load using the load balancer. Say that's now routed to the web server. The web servers, like we have seen before, it caters to the needs of any static request. So you search for a product, the product images and product description, those kind of things can be catered by the web server. Any further processing business logic, it should route the request to the app layer. So here the web server is hosted using EC2 Amazon Elastic Compute, and the EC2 has auto scaling. So if you go for pay as you go model, then the compute is automatically scalable, and you will pay only for what you have used for the compute time. So this is highly available because it's in a failover scenario. So there will be a primary and a standby. So highly available, highly scalable, and with low latency, because there will be a server available in your region and availability zone for your access. Faster access using a cloud front or content delivery network. For example, if you're accessing Amazon.com from India versus users, so the region for India will cater to the needs of Indian customers, versus the region and availability zones based out of US will cater to the needs of North American customers. So that's how, with the content delivery network, the latency is reduced. So now that's coming to the app servers. Like I mentioned, in the microservices architecture, we are dividing the functionality into microservices, loosely coupled, highly independent, and caters to a particular functionality which is independent of each other. Say for example, users could be one service which helps you to log in and authenticate. Orders, anything related to place the order, track the order, order status, that could be another microservice. Recommendations, analytics, cart, product, search, each functionality can be fine-grained into a microservice, could be containerized using Elastic Container Service. So this helps you to run this application as a containerized service, as a managed service. So you don't need to bother about underlying infrastructure and other non-functional requirements like scalability, availability, and resilience. So that is taken care by this managed services, where you have to just focus on the application functionality and the code base. So now, anything, for example, you're looking for, how do we choose the databases? So here there are two kinds of databases chosen, and why. So for example, the users and orders, so these details should be highly consistent. So what I'm logging in, what are my payment details versus yours, should be highly consistently available in the database. That's why we have chosen RDS, so Amazon Relational Data Store. So this is a RDBMS, just highly consistent for customer orders, payments, and user details. And here we also have chosen a failover scenario for high resiliency. So RDS active, and there is a replica of RDS standby. So if there is one database has any problem, then the standby will pick it up. So it's highly resilient. Similarly, we are choosing DynamoDB, which is a NoSQL database, and why and for what kind of data. So we are choosing this DynamoDB, which is cost efficient, NoSQL database, highly available and scalable for unstructured data where it need not be consistent, like products, search, and those kind of data, which also could be indexed via Amazon Elasticsearch Service for faster results and low latency. So that's how we have the front end, we have the web server, the app servers hosted with EC2 auto scaling, and then we have the load balancer for distributing the load, and we have the databases, different databases for different kinds of data, and the CloudFront for content delivery network for catering to the customers closer to their region. And finally, we can also do the recommendation based on user history using AWS personalized, and also it could be trained the models via AWS SageMaker, which will give you personalized content and recommendations when you log in your homepage. So this is how an e-commerce microservices architecture can be designed using AWS.